Alan Kettle-White, if you could please start sharing your screen. And Alan's going to talk to us about lice infestation risk in Argyll sea trout. For those of you who don't know Alan has been working for the Argyll Fisheries Trust since 1999 and is the senior biologist and manager of the trust. So Alan, if you are okay with your presentation, or?
Hi Charlotte, can you hear me?
Yes, I can hear you.
Right, okay, we've got an issue here where I can't share my screen. I did send the talk to Sean, I think, so if you can present from there, that would be great.
No problem. I think Sean or Leanna's going to be able to share that instead.
Yeah, no problem, Alan. I'll get that as soon as I can.
Sorry, I hoped to sort this out beforehand, but we were jammed in the lobby.
That's okay. A couple of technical glitches today.
No bother. I'll look into the meeting settings for the next speaker as well, because the creation of the new meeting might not have captured the setting that allows externals to share. So just bear with me.
Maybe just in a way of introduction, this work really looking at the lice infestation risk to sea trout is born out of probably what's over 20 years of work now sampling sea trout in coastal environments and looking at sea lice burdens, particularly in relation to aquaculture production. So what we needed really, although we had good information describing the burdens of sea lice, we didn't really know what effect that would have on that individual fish, or no way of describing it, and also to the population. So if we move on to the next slide, please, Charlotte. Sorry, Sean.
Yeah, Sean's got it there.
So we looked at this further into using a risk index developed within a wider risk assessment framework, which has been developed in Norway and described by Taranger, I hope I pronounced that right, and his co-workers in a very good paper in 2015, which includes a number of aspects related to aquaculture, including escapes and other things related to aquaculture effects on wild fish. So the tool attempts to quantify the increase in lice-related mortality on sea trout, or if that fish with a high lice burden returns to freshwater, what the impact is in terms of reduced seawater growth for that fish and future compromised reproduction. And obviously that will move into the next year class. Particularly interesting to see the work done by the Assess project and how that might feed into learning more about the effects of early returning sea trout into freshwater and compromised reproduction. Obviously this work is based on sea trout. Salmon smolts are moving more rapidly out of our study areas, so the information doesn't really relate to them directly, but may relate to infection pressure in that area when they are migrating, because most of this work is done sampling in May and June when salmon smolts are also leaving the area. So it differs from the SFCC protocol, which looked at length of fish and looks at two groups of fish, one group being less than 260 millimeters in length and the other group above. This tool actually looks at the number of lice present in relation to the body weight of fish, number of lice per gram of fish, if you like. Okay, Sean, we move on. So looking at the lice-related risk to individual trout, the framework assumes that the small sea trout, that's the ones less than 150 gram, will suffer the percentage related marine mortality or compromised reproduction potential if they are infected at different levels. So 100%, we are looking at levels of 0.3 lice per gram, and this system looks down the scale, if you like. 50% of those fish are affected if they have between 0.2 and 0.3 lice per gram, and that scale falls to 20% at 0.1 and 0.2 lice per gram. And there is assumed that there's no lice-related mortality or change in behaviour with fish of less than 0.1 lice per gram. So, as Alan hinted to in his previous talk, there is this in Norway, there's this traffic light system, so then that makes that information a little bit more easy to communicate, as in the table at the bottom. Okay, Sean, we move on. So from looking at individual fish, we can then translate that to the sample group and maybe what that says about the population. So we then are able to calculate the risk of those 4 different groups. In the table on the slide there, you can see there's an example of 79 fish which we sampled, and the numbers of fish that fell into those different groups of lice per gram. So we end up at the end by totaling those risks into a figure of 51%. So in another paper, they described a kind of way of translating that into low, moderate or high risk to that group of fish that we've sampled. And so we ended up with a total risk of 51% in that, which would fall into that high category of more than 30% of the fish affected. And we have the moderate groups of between 10 and 30%, and the low impact on the fish with less than 10%. Okay, we'll move on, please, Sean. So we can then present that kind of information to our stakeholders, other fishery interests, and particularly presenting that data to fish farmers. So for those more familiar with looking at these kind of data, we retrospectively fitted that technique into our historic data. So we end up with some sites with data coming back to 2002 up to 2021. See, there's a nice gap there, a nice COVID gap missing in our data in 2020. But this describes the proportion of the fish that were sampled and the categories that they fall into. So it's a very good visual way of describing the actual effect on the fish that were sampled and possibly the fish population we were looking into. Okay, we'll move on, Sean. Okay, so looking at this in terms of specifics related to different sites that we've been looking at over the years. In the first example, we'll look at Loch Fyne. That's the site in the Sound of Bute, which is the middle sampling site. That's the blue triangle on the map, and the red dots represent the fish farm areas. Okay, we'll move on quickly, Sean. So for Loch Fyne, we can see for 2021 that our lice-related risk was low, where we only had a total risk of 1.24%. So in the table on the right, we can see the number of samples for 2021 was 82, and we only have very few fish in the higher risk category. And looking at that data going backwards, we can start to see some trends, if you like. So from 2012, really, we have a kind of high impact year every 2 years, but that risk has been falling over time. So from 2012 round to 2018, we're seeing a high risk to the population down to a moderate risk. And for the last couple of production cycles on farms, we are now seeing a fairly low risk. So what looks to be an improving picture in the Loch Fyne scenario. Okay, Sean. Okay, so the new kind of ingredient into this mix, if you like, of local management is we're now getting some information on the sea lice numbers on farm fish, specifically the average number of adult female lice. And so for Loch Fyne, which is further north than Loch Ridden, at the head of Loch Fyne, our sampling site, we can see some sea lice data from fish farms, this being in the second year of production when sea lice numbers are expected to be higher on farm fish, and potentially the number of lice larvae in the environment may also be higher. So we can see from the graph there that the average sea lice numbers on farm fish in Loch Fyne were lower than the code of good practice. It went down at 0.4 down to 0.2 average female lice per fish. Obviously, the number of larvae will be dependent on the number of fish in the water, but over this time the farm fish are being harvested out, so the number of fish or hosts are reducing over time. So we can then compare that to our what we see on the wild fish. Okay, Sean.
Okay.
So here we're going to look at the total lice-related mortality as a percentage of samples on fish less than 150 grams on the left, and on the right we can see them for fish that are larger than 150 grams. So for 2021 we saw the sea lice numbers on farm fish were quite low, and that was reflected in the 2021 figures on wild fish, where we have a low lice-related risk represented by the green bars. And looking back historically, we can see a lot more red in our graphs going back to the earlier years, and this represented a period in Loch Fyne when there was mixed production. We had both year classes in terms of there was no fallow, no coordinated fallow, that is, or production. So that was changed in the early 2000s, where we only had 1 year class of farm fish in Loch Fyne, and there was a fallow introduced, and arguably sea lice treatments have improved. So we kind of reduced the impact on sea trout in terms of the number of lice we were seeing on them. And even in the second year of production, we were seeing, for smaller fish anyway, mostly low mortality risk, except for 2019, where we had high lice numbers on the fish. But if we look again at the graph on the right for fish that are greater than 150 grams, we see those risks were slightly higher, even though the sample sizes, we must remember, are lower for larger fish. We don't have a big sample numbers on those fish, but those fish are likely to be wandering further away from our site and maybe interacting with more lice in different areas of the loch. So you see that maybe the pressures are slightly different further away from our sampling sites. Okay, Sean?
Just 2 minutes left, please, Alan.
Okay.
Thanks.
So moving north, we're going to look at Dunstafnage. Just move this one on, please, Sean. And here we see the farm lice data was slightly higher in the period leading up to our sampling. Okay, move on, Sean. Okay, this is looking at Dunstafnage. We see a different picture where we have the higher lice numbers on farm fish and a history of high percentage mortality found on sea trout. So you can see that very strong pattern in the graph on the left, where we have a high risk to the sea trout we were sampling in every second year, and that represents the second year of farm production when sea lice numbers are higher on farm fish, and that's being directly translated to what we're seeing to the risk on the wild sea trout. Okay, Sean. Okay, there's just a couple of papers of interest that have come out from Norway, from Taranga and his co-workers, which are, if you would like to look more deeply into this topic, you can refer to those papers. Okay, Sean, that's me.